Hi, today we are going to talk about one-to-one functions. Let's go ahead and take a look at the problem for this section. So, the question is for each function graph below, state whether it is one-to-one. And this is the issue that is connected to the horizontal line test. Simple answer is that if a function passes the horizontal line test, then it is one-to-one. What does it mean to pass a horizontal line test? If all horizontal lines cut the graph in at most one point, then it passes the horizontal line test and it is one-to-one. Stated in another way, if any line cuts the graph in if any horizontal line cuts the graph in more than one place, then the graph does not pass the horizontal line test and the corresponding function is not one-to-one. Let's go ahead and check this. So I'm going to explain a bit more as to what the issue is here. So we have two kind of tests. One is called the vertical line test, and the other one is a horizontal line test. So this is all based on a traditional setting. Traditional setting used in almost all the textbooks that we use is that you have X set up horizontally, Y is vertical, and we are investigating some picture that is here. We have two questions. Is this a graph of a function or not? And is that function one-to-one or not? Okay, more precisely stated, we are talking about y as a function of x. Y as a function of x. I'm saying that because in the future you're going to see, well, there are more than just two letters in science. It's not that everything is x and a y. And also it's not that every time you're going to see one horizontal and the other one vertical the way you're used to, so you have to have a bit of a deeper understanding as to what the issue is. So here is our traditional setting: x horizontal, y is vertical, and we are describing y as a function of x. Sometimes a picture is given to you and the question is this a function or not? So for example, here I've drawn something, it looks like a bit of a signature. Again, this is x and this is y. Is y a function of x? The answer is no, because there are vertical lines that cut the graph at more than one place. Imagine you're trying to give a person a place to meet, and these are two avenues, Avenue A and Avenue B. Avenue B happens to be not a straight street, and then if you say, well, meet me at the intersection of A and B, well, that's not enough for the other person to figure out where he or she is supposed to meet you, because, well, there are two intersections. Very simple. Now, for a function, we always insist that for a given input x, it has to have one output y. We do not admit possibility of multiple outputs. And for that reason, we say this is not a function of this graph does not pass vertical line test, and then we say y is not a function of x, and sometimes we make it even more abbreviated. We just say not a function of x, assuming that the person who is listening to us is agreeing with us that we are talking as y in terms of x. So we just say it's not a function. Okay, once something is a function, the issue comes up. Is it a one-to-one function? What's the issue here? Well, for a function, 1x corresponds to 1y. The other side of the coin is it that 1y corresponds to 1x? So suppose I consider this y. What x corresponds to that? Well, I draw a horizontal line. So, well, if I had started at this x, I would be at that y. But also this x will do the same thing, and so does this x will do the same thing. That is, starting at any of these x's, x1, x2, x3, we arrive at the same value of y, in which case we say this function does not pass the horizontal line test, and as a result we say it is not one-to-one. As opposed to what? Well, many of the very simple functions are one-to-one. So here is the simplest of them. Here's this function is one-to-one. 1x corresponds to 1y. So if you cut this thing with any horizontal line, it just cuts it once. Some students get confused here and say, well, look here, it cuts it only once. That's fine, yes, it cuts it once over there, but the issue is there any line which cuts it more than once? Not that there are some lines that cut it only once. Is there any line that cuts it more than once, in which case it's not passing the horizontal line test and it's not one-to-one, even though on some pieces of it might look one-to-one. Some of the problems that you come across here, they show you a discontinuous graph where it is made out of some dots. Remember, a filled in dot means the point is in the graph, and an empty circle means that point is clipped off of the graph. So that a graph could look like this, just a bunch of dots. Does it pass the horizontal line test? Well, this one, we notice that, well, each horizontal line that we consider either doesn't cut at all, or it just cuts once, as opposed to what? As opposed to a situation like this. So you can have something like that, and then there could be a horizontal line that passes through multiple points, in which case we are going to say this is not one-to-one. Why is this significant? Well, you come across this kind of issue in daily life. Suppose you have bought tickets for something, and then you go and see somebody sitting in your seat as if there were two tickets sold for the same seat. This doesn't happen in stadiums, but it does happen in airports. Sometimes the airline sells more tickets that there are seats available on an airplane, and then at the end they have to buy some of these tickets back, and becomes a rather nasty situation. So, but what we have in mind, later on we are going to have some functions that are not one-to-one, and then we have to find a way of remedying situations as in this case. The simplest situations where this issue of not being one-to-one happens is in the case of our trusty parabola. So if you look at the function y equal to x squared, one of our very basic functions, this function is not one-to-one. Very simple. Draw just about any line, it cuts it more than one place, and if you start at this final destination, you want to go back to where you came from, you have two possibilities. Let's do this thing for a simple example. Suppose you are at point y equal to 9. You want to know, where did this number come from? Well, 9 is equal to x squared, so you have 9 is equal to x squared, and x can be 3, but also x can be minus 3. So there are two numbers that give rise to that number 9. And so this situation is a bit problematic, that you have two possible outcomes. Well, how do you choose between the two? Well, essentially you have to flip a coin for them. Where do we see this issue? The issue comes up in a function that's called square root function. Square root function. So if I have square root of 9, what is the number that comes out of this? We have to make an agreement as to which one of these things we mean. Square root of 9 is talking about a number that when you square it you get 9. Well, there are two possible numbers. In this course and all the future courses that you are going to take, the assumption is that the square root of 9 is 3. Okay, so this is by definition. So if your high school teacher said square root of 9 is plus or minus 3, well, perhaps he had some reason to say that for remind you of a certain activity in the algebra steps, but from now on you're always going to think that the standard definition that we have, square root of 9 is just number plus 3. Let's practice thing again. What's square root of 16? The answer is just 4. It's not plus or minus 4. The answer is just 4. Square root of 25, what is that? The answer is just 5. Sometimes students get a bit confused. What's square root of 0? Some students think that it doesn't exist. Well, there's no problem there. This one we can't go wrong. Square root of 0 is just a number 0. Later on, perhaps we are going to come across, well, what's square root of a negative number? Well, if I have negative 1 here, what x corresponds to that? Well, there is no x. There is no number on this line that if I start at that point, I end up at minus 1, for the simple fact that minus 1, the line at minus 1 doesn't even cut my parabola. So simply we say this is does not exist. Well, that's a little bit of a strong statement. It does not exist on real numbers. You are going to come across this issue later on. Well, it's a different kind of a number. It's a so-called complex number or imaginary number. Okay, so to restate, a function passes a horizontal line test if no horizontal line crosses the graph more than one point, and in that case we say the function is one-to-one. Okay, so that brings us to the end of this short lecture. Until next time, good luck and God bless.